To draw the following inequalities without a graphing calculator really involves understanding the parabola. And we really have to go back to the other unit, to the second unit where we were doing parabolas, and you need to know how to graph parabolas. So that's very important. So for the first inequality, we have this in the vertex form. So I can locate the vertex 2 over 1 down. I know it's a parabola facing up, so I want to get a table of values and get a few coordinates. Okay, so I'm going to use 3 and 0. I'm going to use -1 and 0 as my two symmetrical points. I'm going to use a couple more points just so that I have some coordinates. Now we could always use a 1 over 1 up, 1 over 3 up, okay, or 2 over 4 up. You can think of it that way. Okay, since it's a basic non-expanded parabola, and we have some coordinates here. So this is a 2-variable inequality, so the boundary is a line, and it's not equal to, so I'm going to draw my line as a dotted line. And I want the area above, so y is greater than, so I'm talking about above. And again, if we're not sure, we can always test a coordinate. For this next one, it is a parabola that is below. Okay. Now it is given in the general form, so I do have the y-intercept. However, I don't really know where the vertex is. So we can try factoring this and get some zeros. This happens to be, it looks like it is oh no, maybe it's not factorable. Okay, so well, actually it does look factorable. So let's factor this. So there's some options here. We can use VAT's formula to find the vertex and do it that way. We can use the factored form. So I'm going to use the factored form. And I can get the zeros, and from the zeros I can use some symmetry to get the vertex. Okay, so I factored it like this. So I have a 0 at -3, okay, a 0 at +1, okay, and I have a y-intercept here. I can see that my vertex is going to be halfway between -3 and +1, so it's going to be at -1. So I'm going to do a table of values. At x equals -1, I have a value of +4, -1, +4. So I have symmetrical points here. I've got my y-intercept. I also know that there's a symmetrical point about that y-intercept. And I have a parabola that's facing down. It's not equal to, so I'm going to draw my boundary line as a dotted line. And so those are my two parabolas. And what I'm looking for is the area below the blue line, because it's less, y is less than, and the area above the red line, because y is greater than in that case. So to resolve both of those inequalities, really I'm looking at this region in here. Okay? So I can test this by just testing a coordinate. I'm going to test x equals 0, y equals 0, and it has to fit both inequalities. Now, based on this, it should fit the blue one, but not work with the red one. So when I test it in the red, okay, so I'm going to do my test here. Oops. So my test, I'm going to test 0, 0 in the red, and I end up with 0 is greater than 2 squared minus 1, and that does not work. Okay, that seems to be correct for that. When I test, and because it doesn't fit one of them, we already know that this region doesn't work. Okay, now if we test it we don't really need to test this anymore because we already established it doesn't work in one of them, but it does actually work in the other one, right? So it does work. So it's below, but not above. So if we want to be concise about our test, we really need to test all regions. So this region out here, this region here, this region here, this region here, this region here. So I really want a positive test to know that the green region that I've shaded is the correct region. So I'm going to test, let's use that coordinate. That's clearly in the region. So it's -2, +1. So I'm going to test -2, +1 in both of the equations. So I get 1 is greater than 0 squared minus 1. That works. If I test it in the second one, I'm going to get 1 is less than, it's going to be -2 squared, negative, and negative is +4, plus 3. Okay, when I work this out, I get 1 is greater than -4 plus 4 plus 3. It works for that one as well. So it works in both. And maybe I should show the test. This test was for the red equation, and this test was for the blue equation. Okay, and it works for both. It's a check for both. That means that that coordinate at -2, +1 is the solution, is in the right region for our solution to both inequalities.